6-4, number 38, find the derivative. The function that we have is y is equal to the natural log of 5x plus 2 divided by 7x minus 8. There are two ways that you can do this problem. One way is to see that we have a composition of functions where the outside function is natural log and the inside function is this quotient. And to find the derivative, you could use the chain rule. You would find the derivative of the natural log function, which is 1 over the argument, and then multiply by the derivative of the inside function using the quotient rule. But there is an easier way you can do this problem without having to do that much work. And that is to begin by rewriting the right side of the equation using the quotient property of logarithms. And I'll show you how to do it that way. So here we have the quotient property of logarithms. If you have the natural log of a quotient, you can write that as a difference of two natural logarithms. So that's what we're going to do here. We have the natural log of a quotient, and we're going to write that as a difference of two natural logarithms. So we'll have y is equal to the natural log of 5x plus 2 minus the natural log of 7x minus 8. Why do we want to do it this way? Because now it's much easier to just use the chain rule to find the derivative of each of these two natural log functions and subtract. So the derivative of natural log is 1 over the argument. So for the first function here, we will have 1 over 5x plus 2, but then you have to use the chain rule and multiply by the derivative of the inside function. The derivative of 5x plus 2 with respect to x is 5. And you have minus the derivative of this function here. The derivative of the outside function, natural log, is 1 over the argument. And then you're going to multiply that by the derivative of the inside function, 7x minus 8. The derivative of 7x minus 8 with respect to x is 7. So here's our final answer. You can leave it like this. If you wanted to go a bit further, you can try to subtract the two fractions by having a common denominator, but it's okay if you don't do that.